Hi there and welcome to our next edition of our C5 How Much Quantitative Chemistry topic. Now today we're going to be looking at masses of compounds and elements, and we're going to be looking specifically at how much of an element might be in a compound. Anyway, here are our objectives. Okay, so our objectives for today, where we're looking at masses of elements and compounds, you should be able to calculate the mass of different elements and compounds, and even elements in compounds, and be able to work out the empirical formula of different compounds, and we'll look at what the empirical formula is in a moment. Now last time we looked at molar mass of particular chemicals, and today we're going to do exactly the same. Now the first example we're going to look at is if we took a mass of 79.5 grams of copper oxide. We can have a look at how much we actually have in there. Now the molar mass, coincidentally, of copper oxide, we can work it out. It's 63.5 for the copper plus 16 for the oxygen, which coincidentally gives us 79.5 grams per mole. Now that's the mass that we actually have. Now within that means that 63.5 grams is copper and 16 grams is equal to oxygen. Okay, now I think what we'll do is we'll just have another go at another one. This time we'll make it a little bit more tricky to do. Now 50 grams of calcium carbonate. Now if we try and work out the molar mass of this, we've got calcium in there, which has a mass of 40 grams per mole, plus carbon, which is 12 grams per mole, and then we've got 3 times oxygen, which is 16. Okay, so we've got 48 plus 12 is 60, plus 40, that is equal to 100 grams per mole. Now that means that we've only got 50 grams of this here, so the relationship between 50 and 100 is it's roughly half, so in there we will have half of 40 is 20 grams of calcium. We'll have 6 grams of oxygen, and 48 divided by 2 is 24 grams of oxygen, and if we add all of those up we should end up with the 50 grams. Now the percentage composition of a compound is roughly what we've just looked at, where we've looked at the mass of the element in a compound, whereas this looks at the percentage of the compound. So if we take that first one that we did, which was how much copper was in copper oxide, so if we've got the molar mass is 79.5 for the copper oxide. Now the molar mass of copper is 63. Now very simply, to work out the percentage composition, we have the mass of the element divided by the mass of the compound, and we multiply that by 100. So if we substitute these in, okay, so the mass of the element for copper here is 63.5. The mass of the compound is 79.5, which gives us a percentage of 79.9% copper. Okay, so we'll have another look at another example. In fact, I think we'll do a couple of examples. Now the first one we'll do is the mass of nitrogen in ammonium nitrate. So 8 grams of ammonium nitrate contains 2.8 grams of nitrogen. Now, if we can remember what ammonium nitrate is, I'll just write the formula in here. It's NH4NO3. Okay, so to work out the percentage composition, we've got the mass of the element, which is 2.8. The mass from here, the mass of the compound is 8.0. We multiply that by 100 and we end up with 35%. Okay, so we'll have a look at a final example. Now this is where we might need to think a bit carefully about this, because why do we want to know the amount of iron in iron oxide? Now iron oxide here, FeO3, is actually the ore that we get iron from, and obviously iron's quite important in the construction industry. So iron has a mass of 56 and oxygen has a mass of 16. So for iron oxide we've got 2 ions and 3 oxygens, so we've got 2 times 56 plus 3 times 16. So that gives us 112 plus 48. So to work out our percentage composition, I'm going to just try and, I don't want to do that. Let's leave that where it is. To work out our percentage composition, the mass of the element is 112. The mass of the compound here is 160, which means that it is 70%. Now the empirical formulae is very simply the most simple ratio of elements to that are in the formula. So we'll have a look at a few very simple ideas. Now we'll first of all focus on the alkanes. Now if we take the first one, which is methane, that has the formula of CH4, and that is the empirical formula. The ratio for every carbon, there are 4 hydrogens. Now if we take the next one, ethane, C2H6, now we can divide both numbers by 2, which gives us an empirical formula of C1H3. Now if we go on to the next one, C3H8, again we can't divide those, so the empirical formula will be that one there. Now if we look at alkenes, alkenes have C2, this is the first one, C2H4, both can be divided by 2, so we've got C1H2 as the empirical formula. We've then got C3H6, again divide by 2, C1H2, and it carries on like that for the next one as well, C4H8. Okay, so they all have this empirical formula. Now there are 2 ways that you can calculate the empirical formula, but you need to know some information. You need to know either the percentage composition of the compound, or you need to know the mass of each compound. Now I think what we'll do is we'll go through a simple example to try and work this out. Now what you need to do first of all is, first of all, you have to list the elements that you have in there. Okay, so we'll do this with an example. Okay, so we're going to look at a hydrocarbon that is 75% carbon. So in there we'll have some carbon and some hydrogen. Now it's 75%, so we have to divide that data, 75, by the relative atomic mass. So that would be 75 by 12, and as it's a percentage, this will be 25%, and that will be 1. So 75% divided by 12, I'll tell you what I'm going to do. I'm going to move a couple of bits around. Hang on one moment. Okay, let's move that to there, and let's move that up to here. Okay, right, so 75 divided by 12 gives us a value of 6.25, and 25 divided by 1 equals 25. Now that is the smallest number, so we divide by that number here, which gives us a value of 1, and that divided by 6.25 gives us a value of 4, which is our ratio. So we've got a value of C1H4 as our empirical formula. Okay, so again another lesson of with a bit of maths in it. I hope you've understood that. We will do more of that in the lesson. Just to remember that we need to be aware of our molar masses and what we're dividing by and what we're calculating. So hopefully you'll have a go at the questions and you'll be fine with those at the end. Anyway, I'll see you next time. Bye bye.